Hi guys, it's me again, Angie, and welcome to another video. So for today's video, I'm going to discuss you the summary of chapter 8 in Cisco. So before that, I'm going to open first my NetAcad. So to know the topics inside chapter 8, we must first we should launch course. Then chapter 8. But before it, we are going to look first, to see first the topics inside chapter 8. Chapter 8 is entitled Subnetting IP Networks. For subnetting an IPv4 network, under it we have network segmentation, broadcast domains, problems with large broadcast domains, reasons for subnetting, and under subnetting an IPv4 network, we have octet boundaries, subnetting on the octet boundary, classless subnetting. Classless subnetting examples, creating 4 subnets. Next is subnetting A16 and 8 prefix. Under it, we have creating subnets, creating 100 subnets, calculating the host, creating 1000 subnets with a network, with an 8 network. Then next to it is subnetting to meet requirements. Under it, we have subnetting based on host requirements, subnetting based on network requirements, network requirement example. Next to it is benefits of variable length subnet masking, traditional subnetting waste addresses, variable length subnet mask, basic VLSM, VLSM in practice, in chart. Then next to it is addressing schemes. Under it, we have structured design. Next is network address planning. Planning to address the network, assigning addresses to devices. Then next is design considerations for IPv6. Under it, we have subnetting an IPv6 network. Under subnetting an IPv6 network, we have the IPv6 global unicast address, subnetting using the subnet ID, IPv6 subnet allocation. Then for the summary, there are class activity entitled Can You Call Me Now? Packet Tracer Skills Integration Challenge. And lastly, we have subnetting IP networks. Then for the introduction for Chapter 8 Subnetting IP Networks. Designing, implementing, and managing an effective IP addressing plan ensures that networks can operate effectively and efficiently. This is especially true as the number of host connections to a network increases. Understanding the hierarchical structure of the IP address and how to modify that that hierarchy in order to more efficiently meet routing requirements is an important part of planning an IP addressing scheme. In the original IPv4 address, there are two levels of hierarchy, a network and a host. These two levels of addressing allow for basic network groupings that facilitate in routing packets to a destination network. A router forwards packets based on the network portion of an IP address. When the network is located, the host portion of the address allows for identification of the destination device. However, as networks grow with many organizations, adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level to the network hierarchy, creating, in essence, three levels such as, such as a network, a subnetwork, and a host. Introducing an additional level to the hierarchy creates additional subgroups with an IP network that facilitates faster packet delivery and added filtration by helping to minimize local traffic. So for this chapter examines in detail the creation and assignment of IP network and subnetwork addresses through the use of the subnet mask. So let's proceed to my PowerPoint presentation for Chapter 8, Subnetting IP Networks. This chapter began with an introduction to routing, including a look at the difference between routed IP and IPX and routing RIP and IGRP protocols. The communication process on a simple one-router network was described step by step and included an overview of the different processes that take place when a host on one network attempts to communicate with a host on another. A more complex example is involving multiple routers and networks demonstrated the way in which routers will forward packets to the next hop address on their journey between a source and destination host on different networks. Then, a look at static routing provided an overview of how this technique allows an administrator to manually define the path that a router will choose in reaching a network. This included a look at the IP routing table and the syntax of the IP route command. The concept of administrative distances was also introduced in order to illustrate how a router makes decisions on which routing table entry to use when a path to the same network is learned in different ways. For example, a static routing table entry will always be considered more trustworthy than a route learned from a routing protocol by default. Next, a look at dynamic routing demonstrated how routers are capable of exchanging routing table information with one another, both through the use of distance, vector, and link state routing protocols. The major differences between both types of routing protocols were outlined, as was the concept of a hybrid protocol. The danger of routing loops was also discussed. including a look at the techniques used by distance vector protocols to avoid these loops. Next, an overview of the distance vector routing information protocol outlined its major characteristics, timer values, and finally the commands to configure and monitor RIP on a Cisco router. The interior gateway routing protocol was also discussed, including an overview of this configuration. Default routing was looked at as a way to configure a gateway of last resort, the next hop router to whom a router will send packets destined for unknown networks. Lastly, IPX routing was looked at next, including the fact that IPX RIP and SAP messages are broadcast between routers automatically after issuing the IPX routing command. The IPX routing table was looked at, as were the commands to monitor IPX, RIP, and SAP broadcast traffic. The show protocols command outlined a quick and effective way to obtain information on a router's interfaces, including their current state and configured addresses. So this is the end of my presentation. Thank you for watching and see you on my next video. Bye! Thank you.